So let's look at the little definition that we have for the odd function. So it says functions that are symmetric with respect to the origin are called odd functions. So that's with respect to the origin. And that means for every x in the domain of f of x, negative x is equal to negative f of x. So f of negative x is equal to negative f of x. And it is symmetric with respect to the origin. So let's look at that example. Say we have a function that is given to us. So this one's symmetric with respect to the origin. Oops. Origin. There it goes. Okay, so say we have a function given to us. F of x when it's x cubed minus 2x. So what this means is that first we have to turn it into negative, well, we have to turn it into f of negative x first. So we have negative x cubed minus 2 negative x, because we turn all the x negatives. And so once we have this, we solve for it. So we see that negative x times negative x times negative x. Well, this is positive x, but times the negative x, that equals negative x, right? So we're going to get negative x cubed plus 2x, because negative and negative is positive, so it becomes plus 2x. Plus 2x is equal to, we make everything negative because remember it's a negative f of x when it's for an odd function. So we make everything negative f of x, which is negative f of x, x cubed minus 2x. We use the original function. And we got back to the original function because this would have stayed negative. This would have become negative because it would have become negative, because negative times a positive equals a negative, and negative times a negative equals a positive. So we got back to the original function. We did. So that means that it is an odd function. It is an odd function because it went back to its regular position, so it is an odd function. And if we were to graph this, we would have got something like so. So it's symmetric respect with the origin. Mines really don't look symmetrical because of the way that I drew it, but it's supposed to be symmetrical to the origin. So this means that it is odd. And an odd function will always have one going up and the other one going down, or one going down and the other one going up. It's never going to have like both going up or both going down as an even function would. But to go over this again, we had the function f of x, our regular function. We turned it into f negative x because that's the way it goes for odd functions. It has to be f of negative x equals to negative f of x. So we turned it first into f of negative x, and we solved for it, and we got negative x cubed plus 2x. And then we did negative f of x, and we solved for that, and we got back to our original function, which indeed told us that it was an odd function. So that's how we get our even and are odd functions. And remember, for even, they're both going up or both going down. And for odd, one is going up or one is going down or the other way around. And for even, you have to put f negative x equals f of x. And for odd, it has to be f of negative x equals negative f of x. But they both, once you solved for them, they both lead you back to your original functions. If they don't, then they are not even and they are not odd. But we are not done. We're going to talk about neither. When a function is neither odd or neither even. So let's do an example for this. Say we have the function four to square root of x. We have to see if it's even or odd or neither. So let's the first step in everything is to set it to f of negative x. So 4 and negative x, because we set it to negative, right? And then we see that that is not going to be even. So we have 4 to square root of negative 1 x, because we set it to 4 and negative 1 and square root of x, because we set it to negative f of x. And once we solved for that, we noticed that that would be more of like a f I square root of x, because a square root of 1 is I, if you did not know that, but we will touch into that later, so don't worry. But the point is that f of negative x is not equal to f of x, nor negative f of x. So it is not odd or even. It's neither. It's not odd nor even. And if we were to graph this, we would have got something like this. And that's not odd or not even. So that would be neither, because the function did not return to its original form when we solved for it. So it is neither. So once again, for neither, we just do the same step. We solve it for f of negative x and didn't go back to its original. We solve for negative f of x, it didn't go back to its original. So that left us with it is not odd nor even. And the graph itself proves it, because it's a root. And for it to be odd or even, one would have to go both up or both down for it to be even. And for it to be odd, one would have to go up and one would have to go down, or vice versa. And just remember, for it to be even or odd, it has to return back to its regular function when you solve for it. And for this one, it did not return to its regular function. So f of x, f of negative x is not equal to f of x nor negative f of x. So it is not even or odd. It is neither. Once again, the graphs help you a lot, so pay attention to the graphs. And if the function doesn't return to its regular, then it is wrong.